Hello! Today I'm going to give a brief demonstration of the integration between Twistlock and PagerDuty. When Twistlock detects possible security threats, it can generate alerts. It's important for your digital operations team to see these alerts so they can determine whether it might cause downtime or security issues. Let's get set up by going to Manage Alerts, and let's enable the PagerDuty integration. You see we need a routing key to the particular PagerDuty service. Let's go set up a new service in PagerDuty now. We'll call our service Twistlock PagerDuty Test, and we'll use the V2 API, and we'll say these are coming from Twistlock, and add service. At this point, we get an integration key, so we can route the alerts from Twistlock directly to this service. Let's verify that it works, and we should be good to go. So let's save that. Now we're going to create an alert profile, so we can decide what sorts of alerts are sent to PagerDuty. We're going to call this our PagerDuty profile. We're going to enable it, and we're going to select container runtime alerts of all types. And let's send a test across now. Let's see if that went to our service in PagerDuty. Container runtime alerts, and here's our test. Perfect. Everything seems to be working as expected. Now, let's generate some activity. We're going to open a terminal, and we're going to run a container from an Ubuntu image. This is an image that has not yet been seen in this Twistlock environment, so we're going to scan that image and observe its behavior. Let's search for the Ubuntu image. Here we are. We're currently learning its behavior. So far, we've observed that it's likely going to run these different processes. If we run anything else outside of those processes, once this container model becomes active, which Twistlock normally does automatically after a 24-hour learning period, but which I'm triggering manually now, then that will constitute a violation of the model, and we'll get an alert. Perfect. So now in our container, let's generate some activity by running some commands that are outside of the model. First, we'll run top. That was not one of the processes included in the list. In addition, we'll run ls of the /etc directory. Perfect. Let's go look at PagerDuty and see if we have some alerts. Here we go. We have 2 new alerts. Let's take a look at them. We have one alert here that shows in our Ubuntu image that we ran user bin top, launched from bash. That was not in our runtime model. Perfect, that's just what we expected. Let's look at this next one here. Here we can see that bin ls was run, full command being ls of /etc. Again, something that's a suspicious activity, not in the runtime model. Now, let's take the next step. When we want to close the loop and have Twistlock automatically defend against attacks that were detected as alerts, or even block containers from running, we can create a rule. This rule applies just to containers from our Ubuntu image. And right now, if we detect anything other than these explicitly allowed processes, we're going to prevent them rather than simply alert. Perfect. Let's see our rule under defend runtime, and let's see that rule in action. Let's attempt to run top again. Operation is now not permitted. Excellent. Now let's modify that rule a little more. Let's set it to block. And let's run that container again. We ran top, and this time the container was actually terminated. And as you'd expect, we get all of these details in PagerDuty as well. Thanks for watching.